For us now in this part of the chapter, we're going to be talking about solving equations. And to be more specific, this section we're going to start talking about solving exponential equations. Further on down in this section, we'll talk about solving logarithmic equations. And when we're solving exponentials, we're going to have different strategies, and our focus today is going to be on common bases. So, solving with common bases is exactly what it sounds like. We want to go ahead and have the base value the same. So, if we kind of look at this key concept statement here, it looks a little intimidating at first, but it's very powerful for us. And basically what this is saying is then, if I have a statement that has a common base of b, and I know that it's raised to an exponent x on the left and raised to an exponent y on the right, well, I can draw a conclusion from there. The conclusion I can draw is the fact that in order for this statement to be true, x must be equal to y. This is very, very powerful for us. So therefore, if I have b to the x equal to b to the y, I know that the exponents x must be set equal to each other. And that's what the strategy we're going to use to solve our beginning stages of exponentials. So let's take a look at some examples. There's going to be three scenarios for us. And the first scenario is such that it's the best scenario in that we already have our common bases established for us. So just like in our previous statement up here that we were talking about, where we have the bases already established for us, we could go ahead and say, hey, our bases are the same, so therefore this means 2x equals x minus 4. Now obviously we're not done. We go through solve this linear equation by subtracting x to both sides, and that gives us x equals negative 4. And there's our final answer. X equals negative 4. In other words, if I substitute negative 4 in for the x variable, this statement is true. Which obviously makes sense if you're looking, because 2 times negative 4 is negative 8, and negative 4 minus 4 is also negative 8. This again is the best case scenario, or easiest scenario, because the bases are already established for us. The next best scenario is when we have one base that needs changed. So if we take a look at this next example, we see that we don't have the same base, but this should be a problem that has like a little bit of a red flag for us. 25, I understand, can be rewritten with a base of 5. And we know that 25 is actually 5 squared. So if I rewrite the 25 as 5 squared, but I leave everything else the same, I now have the following equation, which from here I could apply the power to a power principle, which tells me to multiply. So this would be 5 to the 2x minus 2 equals 5 to the 3x plus 1. Now my bases are the same. I could set the exponents 2x minus 2 equal to 3x plus 1. And now I have my basic linear equation to solve. Subtract 2x to both sides. Subtract 1 to both sides. I get x equals negative 3. So this is our second best scenario, again, where we just had to change one of the expressions. So if you're playing along at home, you can kind of guess that the hardest situation